Good evening, everyone. My name is Wumi Olaseha, and my group partner is Adam Abenethi. We are Group 11 members here to present Privilege Escalation Escape to Host via Docker. It is very common to hear the word Docker or container, especially in an enterprise environment today. In this presentation, we will be discussing what Docker is, the vulnerability or security risk, who it impacts, and its consequences. We will also go into the technical details of the exploit or the risk and how it works and why it exists. We will also be doing the technical demo. Now, to first start with, we'll talk about the security risk. We are going to be demonstrating that a non-privileged user account is capable of elevating to the privileges granted to the Docker daemon itself by simply allowing the user to run Docker. So Docker run is the abuse or exploit here. Leveraging the common default installation and configuration of Docker, we are going to abuse the privileges granted to the Docker daemon and elevate to a user to the root account. What are the consequences of this? If a malicious user escalates privilege or gain root access in a container, it could execute whatever it wants in the container and can cause havoc. It could upload malicious files or execute a malicious code on the host system. It can stop and destroy all containers running on the host. Start its own containers using malicious code, access database or exfiltrate files in the machine or network. It could also mount files, mount volumes, remove or corrupt critical configuration files. There is a secure method of running Docker, but it is not the default configuration. Therefore, this exploit has a high probability of success. In terms of who this impacts, impacts millions of people and organizations, system administrators, and developers that are running Docker container with root account. Now we will move to the technical component of the exploit with the privilege escalation exploits, meaning that an attacker has already gained access to the system but does not have the permission to further pivot or otherwise achieve their goals. In the lab demonstration, we will use a Debian system. We will need access to two users, a root and unprivileged user. We will also need to install Docker by logging in as root. Now, before I proceed, it is important to also explain what Docker container is and why it is widely used today. VM technology was used to solve the issue of hardware management by virtualizing hardware where you need to install an hypervisor or maybe like a VMware or VirtualBox on a bare metal machine. Then install multiple servers with different operating systems like Windows, Ubuntu, Linux, etc. It can be very challenging to manage VMs as it requires installing all the software dependencies, software update or security patches, and in fact, troubleshooting error could be a nightmare. On the other hand, Docker Container is a lightweight microcomputer replacing VMs to solve these issues, thereby virtualizing operating systems. Container shares the host operating system. It has its own CPU, software, memory, and network, etc. So the principles of Docker is to develop, ship, and run applications anywhere. And they are also ephemeral, that is, it exists only briefly. Docker provides developer the ability to package and run an application in a loosely isolated environment called a container. Docker enables you to create isolation between your infrastructure and application through its portable format and easy to use tooling. So this helps developer to deliver software quickly by significantly reducing the delay between writing code in a local system and running it in production, be it in the cloud or on-prem data center. Containers are lightweight and contain everything you need to run an application. For instance, a developer would want to install microservices such as MySQL, database, and WordPress, and all the compatible application in one server under the VM technology. But with a container technology, The microservices will be deployed and isolated in one container each, so it can be easy to manage any update or patches required, and can easily remove the container if given any error and replace immediately with another copy of the image instead of troubleshooting or doing a new configuration. Now let's talk about how the exploit works. The Docker abuse happens by exploiting vulnerabilities such as insecure configuration or weak access controls, leading to attacker gaining access to the host system resources. Docker allows users to configure the container and how it interacts with the host operating system. And a common example is a container containing a database. Typically, a database, require large amount of storage space. So a system administrator will configure large disk volumes and then want to use the storage space within the container. So this is solved with a feature called volume mapping. Generally, the unprivileged user don't have access to the root and are unable to run Docker. However, we want to escalate the privileges to gain root access. So since Docker can only run as root, then we will need to add the privileged user to the Docker group by using the first command in the screen there. By this, the privileged user is now in the group that has the permission to run Docker. But at this point, the unprivileged user can only run Docker but doesn't have root level access or permission to run sudo command yet. Therefore, using the second command here, we are going to mount a volume that Docker has permission to access, as it is a root level service and our user doesn't have permission to access. So as our user can access Docker and its resources, it will become available to the user simply by being part of the group. The unprivileged user who can now run Docker will also become a root in the container. To permanently elevate the root access, we will then grant the ability to use sudo command, which we will soon demonstrate. So since there is merely access to the files as root, any action taken as root in the container will only be inside the container. However, any modifications to the files will affect the host. So this is the privilege escalation. So the knowledge of handling permissions in daemons that can execute third-party code beyond its binary is a real security flaw in this entire process. Why does this exploit work? We're going to talk about that as well. So this works, the Docker privilege escalation exploit exists because of insecure configuration of container, as Docker was allowed to run as root. So this insecure configuration is run in millions of containers today. In order to prevent this, it is highly recommended not to run Docker as root, but to isolate a container using a user namespaces, thereby limiting access to the system resources. Though some, container runtimes may need root access to run, but containers don't. However, in many cases, developers still run it as root because it's easier. But so root users, as we know, will have access to read and write files. So for containers whose processes must run as root user within the container, you can remap this user to a less privileged user on the Docker host. And the map user is assigned a range of UIDs which functions within the namespaces as normal UIDs, but have no privileges on the host machine itself. So therefore, it is important for organization to set up policy to restrict developers or system administrator from running containers as root. And another solution to this is also to use a robust authentication system, such as MFA or privileged access management, so which can largely prevent attackers from accessing containers and escalating privileges. So now I will pass the ball to Adam to talk about the technical demonstration and show us as well. Thank you.
Hey, everybody, thanks for coming in. This is the technical demonstration on abusing Docker to gain root privileges. As Wumi has already said, we're doing this on a Debian 11 server, but I've already got and installed sudo and ZSH. Those are the two things that are running. ZSH to make it easier to show off what we're doing, and sudo just to save a whole bunch of back and forthing. but I will demonstrate all the permissions are in the right place. So we're going to log on to a Debian 11 server with just those two things done. We're then going to install Docker. We're going to demonstrate a little bit about how Docker works so you can see it live. We're going to do the actual hack, confirm that we've done and exploited, gained our root privileges, and done whatever we want. Wumi's already explained most of the nuts and bolts to you, so I'm just going to actually show you what it looks like. Sometimes it gets a little challenging when you're doing one of these demonstrations to see what's part of the setup and what's part of the actual exploit. So I've kind of themed the background right now. So if you look straight above my head, there's setup part when we get into verifying and confirming that permissions are the way we want them to be or that permissions have changed. Then that will be in the verify, and when we actually come to doing any kind of an exploit or something like that, I'll change the borders to be red and stuff. So take a look around and make sure you're in the right spot. So with that, we'll log into our machine and we'll start with the setup. What we're doing from this system is we are going to log into this server and we are going to elevate and do our actual system administration that's required for this exploit. So right now I'm going to log in as root. We're going to assume that this is before any user has access to the system, but you also get a chance to look and see what root looks like in this shell. So you can see root has a little lightning bolt and stuff like that. So logged in as root, I'm going to update the system. And I'm going to then do a couple more commands that are going to add the capability to install Docker. Now, there's nothing magic here. It's literally the instructions out of Docker. So this is the instructions straight from the Docker install docs. So that's all this is. So I'm copy and pasting these straight from the Docker installation docs for Debian. As I keep going, so each one of these is just taking a command line, taking a line, echoing a line of text into the sources file so that when we do update again, so now I'm going to go get the list, and now you'll see that there's actually Docker for my distribution of Debian in there. So that's all that's doing. Now when I go to install it, I can install Docker CE and Docker CE CLI. So that's going to go and install Docker on this server. So there's nothing there. I'm installing Docker, and I'm going to install it and configure it the way any system administrator would configure it or thinks that they should configure it. All right, so that finished installing. So now we should be able to see that if we run docker run hello world, it's going to download the hello world image and run it. So it didn't have it locally, so it was unable to find it, downloaded the image, and then you get hello from Docker. This shows that this is what normal looks like. When you run the hello world image, this is what it's supposed to look like. Anything else is errors and unexpected. So that was from the root user. Now, if I exit back out to my user, my greedy user, if I run docker run hello world, this user does not have permission to run Docker. We have to go back in and give this user permission. So from here, we're going to give this user permission to run Docker. This is part of that Wumi was mentioning. So this is one of the areas in this default installation of Docker. This is where the major security configuration goes wrong. We have root version of Docker running, and we are assigning a user to that group, assuming that gives them unprivileged usage. We'll see what that means in a second. The first step is the group. So we have now added that user. So when I look at the groups for that user, I can now see they're not in the Docker one. Linux permissions are a little weird. The easiest way to make them take place is to exit out of the server and relog, basically to relog back in. There's other ways to do it, but this is kind of the easier way. So now when I type groups, you can see the Docker one is here. It wasn't there earlier. So when I typed groups earlier, I could see I wasn't in Docker. Oops, I didn't mean to jump around there. Docker wasn't there when I typed it earlier. Now Docker's in there. This user now has permission to run Docker. So I'm going to flip back to verify now. So now we're at a state where our user can run hello world, Docker run hello world. They get the Docker instance running without any errors. Is this a privileged user? Let's find out. Can I look at the shadow file? That's the file that holds the hashes for the users. Nope, I can't look at the shadow file. Can I install software? Apt install fish. Nope, permission denied. Are you root? So I don't have permission to do this. So at this point now, my user can run Docker, but cannot do anything else, cannot elevate any other way. So this is very common, and this is how most administrators want this installation to look. They think this is perfectly fine. They think this is a default. I can hand this out to my developers and my engineers. Let's take a look. I'm going to exit here. Oops, I didn't mean to exit the shell. I will log back in. I just meant to clear the screen so it was at the top. So let's take a look at how Docker actually works now. So once we've examined a little bit about how Docker works, it'll be really easy to talk about this exploit and how this exploit works. So first thing I'm going to do is I'm going to make a directory called Docker Lab. So I've made a directory called Docker Labs, and I'm going to go into it. And in this directory, this is a tasty file on the host system. And I'm going to put that into tasty. So there, I now have a file called tasty. It's in that directory. All right. So that exists on my host directory. So pwd, who am I? So as greedy user in their home directory of greedy user Docker Labs is this file. Now, let's talk about Docker for a second. If I do Docker run, I'm going to do, again, as Woomi's already mentioned, I'm going to do Docker RM to mean destroy the container when we're done, IT to make it interactive, and then I'm going to run Alpine, which is a tiny version of Linux. So this tiny version of Linux just, it's got all the root commands of Linux, but nothing else special, and it's built for containers. And then what do I want to run inside Alpine? I'm going to run a shell so I can see what I'm actually doing. So you'll see this is going to download Alpine Linux, run it, and I'm running inside the shell. Looking in this Linux, if I go to home, I don't have a greedy user folder. I don't have my tasty file. I don't have anything like that. I can make it. So if I make their sample user folder, I can see there's a sample user folder. And if I go into it, I have permission to edit. I can more tasty goodness inside a container. And I put that into tasty container, whatever, and I put that inside the file. I can see it's there. So I've got some sample text. I've put it inside there. Remember, this container is built to be destroyed as soon as we exit. So if I exit, I've closed that container. It's gone. Even if I were to go right back up, run the same command, and go to home directory, it's gone. It's all gone, destroyed. Now, what we do with that is when we run these containers, so let me clear the screen again. So remember, we've got a file in our folder here called tasty. So when I run this, I can do Docker run, and instead of, I'll do the other parts, the RM, the IT. What I'm going to do this time is I'm going to do a volume, and I'm going to include home, greedy, user, Docker labs, tasty. So I'm going to say that file, mount it to home/container tasty. So inside my container, put it on the home directory and call it container tasty. And then I'm going to do the same thing, Alpine shell. So when I run it now, I'm now inside my container again, home, and I now have that file container tasty. Can I read it? Of course I can read it. Now let's do something really crazy. Echo, this is being edited from within the container. Remember, I'm inside the container. I'm inside the container. So I'm editing this container file. I'm adding some text to it. So cat container tasty. I now have 2 lines. This is a tasty file on the host system, and the one I just added from inside the container saying this is being edited from within the container. All right, so I exit out of that. Now, on the host system, the one that I mapped that to, that file called tasty, it's been edited. It's been edited from inside the container. This is the mechanism we're going to abuse right now. So not only are we going to edit a local file, so let's clear the screen again so we can see this all happening live. We got a couple of seconds left to get this demo going. What we're going to do this time is we're going to do Docker run. This time I'm going to mount the entire file system, and I'm going to put it under the mount of the internal container. I'm going to run Alpine, and instead of running shell, I'm going to run change root to mount, where I put the whole host file system, and then run shell. It's going to make my shell look a little weird, but it'll come up. Now I'm going to do one more thing. Instead of editing just any file, I'm going to edit the sudoers file. So that looks something like this. Echo. So the actual line that I want to put in there is greedy user, which is my user, which permissions I want to give it to run sudo, when I want it to be prompted for a password. In other words, I'm just saying you're allowed to run as admin whenever you want. And I'm going to take that and I'm going to put that into a file for the sudoers in the sudoers configuration. The last thing I'm going to do is I'm going to give it the right permissions for sudoers to read it. Otherwise, it's going to say, hey, that's invalid. sudoers.d slash greedy user. So what I've done here, this is the part where I've actually elevated. So inside my container, I edited the sudoers file, gave it the permissions, the proper permissions from inside the container. Now I'm going to exit. Now I've got root level access. So let's see. If I do cat Etsy shadow, permission denied. Sudo cat Etsy shadow, not even prompted for a password. Sudo install fish. Sudo apt install fish. There we go. So that's installing fish. Yay. In other words, I have permission to install software. And lastly, more importantly, sudo-i for sudo interactive, not prompted for a password. Snap. There I go. So at this point now, that is officially, that planet has been hacked. I have hacked the planet and we have gained sudo access across the board. So the real permission was done when we edited the sudo file from inside the container. But at that point, yeah, thanks for checking out the video. And thanks for coming along. And back to you, Boomy, to close us off. Thank you.
Thank you, Adam, for that fantastic demonstration. We have so far gone through the security risk of this privilege escalation in Docker container, and we've seen how it can be exploited and who it impacts and the consequences as well. We also went through the technical component of this, and also we did a demo. And by installing Docker and also assigning privileges to an unprivileged user. So, and finally, we wrap it up by talking about the mitigation of this. So, these are the references as well that we've used for this presentation. Thank you.